So good morning to everyone. EC 8791 Embedded and Real-Time Systems Final Year 7th Semester ECE Regulation 2017 Unit 5 Processes and Operating System. So in this unit we are going to see about the multiple task and multiple process, multi-rate systems, preemptive real-time operating systems, priority-based scheduling, inter-process communication mechanism evaluation, operating system procedures, power optimization strategies for processes, example real-time systems, POSIX and Windows CE, distributed embedded systems, multiprocessor, system on chip configuration and shared memory multiprocessors, design examples, audio players, engine control unit, video accelerators. So in the first class, we are going to see about the multiple task and multiple processes. So task and processes. So what is meant by task and processes? And what is the definition for task and processes? A processes is a single execution program. If we run the program same, the two different times we have created the two different processes. Each process has its own state that includes not only its registers but offers memory. So in some OSs, memory management unit is used to keep each process in a separate address space. In other, particularly lightweight RTOS, the process run in the same address space. The processes that shares the same address space are often called threads. So process is called still under execution. That is called the process. So it's a lightweight process. Then the task are the part of system functionality, but the publication level organization of functionality is often reflected in the structure of program as well. So this is a real-time compressor diagram for the task and processes example. So here we are having the uncompressed data to the compressed form by the means of this data compressor. So the compressor will be in the serial line. So all the characters will compress and it will form a big queue and it will produce the uncompressed data to compressed data. Then what is meant by multi-rate systems? As usual, we are going to see on embedded system in the sense it should be a multi-rate system. So then what is meant by that multi-rate system is a common including automobile engines, printers and cell phones. So in all these systems, certain operations must be executed periodically and each operation executed as its own rate. Okay. So that is an example for this multi-rate system called the engine control unit. That engine control unit will have all the peripherals which is used to be essential to run the engine control unit like oxygen sensor and uh, engine control unit sensors. So likewise we are going to see about in these following slides. The next one is distributed embedded systems. So distributed embedded system means there will be a variety of process elements. That process elements will be connected through this network. So this network will be connected through the sensors, actuators, digital signal processors, application specific integrated circuits. So these are all the whole process elements will be connected through this network is called a distributed embedded architectures. So this is an example for this engine control unit. So engine control unit will have a variety of sensors, oxygen sensors, crankshamper, spark plug, composition of air and fuel consumptions. So likewise, all the sensors will be connected through this automobile engine processes. That process will control all the peripherals which is essential to run the engine. So that engine will control all the fuel composition, air composition, and then spark plug operations. So these are all the examples for this multi-rate system. So multi-rate system will be example for that engine control unit. Okay. The next one is we are going to see about the priority based scheduling algorithm. So what is meant by that priority based scheduling algorithm? The earliest deadline first scheduling algorithm and the rate monotonic scheduling algorithm. Okay. So in this algorithm we are going to see about various scheduling process and how to essentially and how to allocate the process in a priority based manner. Okay. So in this algorithm we are going to see it next class. So in this class we have seen the multi-rate system, process, task, thread, and we have seen that multi-rate system architectures and distributed embedded architectures. So next class we are going to see about the earliest deadline first scheduling algorithm and rate monotonic scheduling algorithm. Thank you.